Hello. In this lesson, we're going to talk about solving quadratic inequalities, right? In the past, we have covered quadratic function, and we have also covered solving quadratic equations in the previous lessons. And this time, we're going to talk about solving quadratic inequality. We actually have addressed these questions, solving these inequalities in the section of quadratic function. But here we're gonna talk about systematically what are the different methods that are available to solve these quadratic inequalities. Okay, example. Okay, example number one. Okay, we use the example to illustrate, right? So the first example, I'm going to address the first method. Right? For example, typical question would be saying, solve for x. Okay, and we're given a quadratic inequality, such as these. Say I'm going to make it +2, right? Just for a variation. So here, we want this to be positive. Okay, so first of all, we're solving an inequality, right? So what the goal is to find all possible solutions, all possible values of x, right? Such that this product is positive. Okay, this product is positive. Okay, so we don't know what they are, right? So this method you can also see as input unknown, right? And the rule of the function is, hold on. The rule of the function is as such, right? It's this product. And we want the product to be positive, right? We want a positive product. So that's another perspective. Regarding this, there's multiple methods, and you're going to probably encounter these situations or for certain, you're going to encounter similar situations in calculus classes, right? How do we solve a quadratic inequalities like that? And you know, for that matter, maybe any polynomials or any functions, right? We're going to address those things in the future examples. But quadratic has been a very typical academic question. So solving its inequality certainly is discussed in many literatures and textbooks. Okay, so the first method is that we treat it as the product of two numbers. Okay, the first method is that we treat it as a product of numbers. So I'm going to put a think out aloud part. Okay, so we treat it as two numbers. Okay, one number A and the other number B. And we want the product to be positive. And of course, A is x plus 2 and B is x minus 3. Right? So we have an inequality at hand. And we also know that principle number 6, right? What is principle number 6? Principle number 6 tells us that if we have a positive number, multiply a positive number, and then the result is going to be a positive number, right? And if we have a positive number, multiply a negative number, the product is going to be negative, right? And if we have a negative number, multiply a positive number, and that product is also going to be, this is going to be negative, and this product is also going to be negative. And lastly, if we have a negative number, multiply a negative number, and the product is going to be positive, right? So we know these basic principles, right? These principles actually will bring us ideas, right? So for example, I can put these two principles together, right? These two principles basically tell us that when the two numbers in product are the same sign, positive times positive or negative times negative, the product is going to be negative, right? And the next two cases is that when we multiply two numbers and the two numbers are opposite in sign, one is a positive, the other one is negative, or one is negative, the other one is positive, the product will be negative. So that's basically what principle number 6 says. Of course, it also says a bunch about the quotient, right? Quotient is similar. So from this perspective, we will observe, we realize if we can figure out the sign for each number, right? So if we think of A as x plus 2, right? And we think of B as x minus 3, right? If we know the sign changes, right? If we know the sign changes, then we can tell, then we can use principle number 6. So the first method we're talking about here is just based on the analysis of sign. So since we don't know what x is, right? And we know from the domain perspective, x can be any real number, right? If you look at the domain perspective, x can be any real number. So if you think about A, right? So let's think about A, right? So I'm going to make a table. Okay. If you think about A, right? So I'm going to put A here. I'm going to put a B on the second column. And you plug in a bunch of numbers for x, right? We don't know what x is. X is what we're looking for, but x can possibly be any real number. But what's interesting about is that we know that when x equals to -2, right, what happens? X plus 2 is going to be 0, right? If you put, and if x equals to -3, what happens? X plus 2 is going to be what? If x is less than -3, I'm sorry, x is less than -2, right? -3 is less than -2. So x plus 2 is going to be equals to -1. So in that case, right? So when x equals -2, x plus 2 is 0, right? If x equals to -3, x plus 2 is negative. In fact, if you plug in a couple more numbers to see the pattern, right? So I'm going to pick x equals to say -4, right? If I pick x equals to 4, then x plus 2 is going to be negative again, right? Because -4 plus 2 is less than 0, it's negative. If I pick a number x equals 0, 0 is larger than -2. In this case, x plus 2 is going to be positive. So do we see some patterns here? So if I pick x equals -1, you can certainly choose you can certainly choose decimal numbers, fraction numbers if you want, right? But what we found is that we discovered something. Is that x plus 2 is positive if we choose x to be larger than -2. X plus 2 is negative if we choose x less than -2. So we must write it down here. Okay, so if, okay, x is equal to -2, x plus 2 is 0, right? If x is less than -2, x plus 2 is negative. if x is larger than -2, x plus 2 is going to be larger than 0. So we realize that pattern is correct. That pattern is correct, right? What does that mean if we put this observation on graph, right? So suppose I have a number line. Okay, suppose I have a number line. So this is my number line, right? And I got a -2 here. I got a -2 here. Okay, so if I observe the sign of x plus 2, right? If I observe the sign of x plus 2 is going to be equals to 0 if x equals to -2, right? If this is number line, so if I choose a number less than -2, which is to the left of -2, then x plus 2 is negative. Negative. Okay. Negative. Oops. Negative. Right? And if I choose a value larger than -2, right? Then x plus 2 become positive. And positive ever after. And for all of these values you choose, right? Any value you choose less than -2, x plus 2 is going to be negative. When x equals to -2, x plus 2 is 0. And x plus 2 will be positive if you choose a value of x which is larger than -2. So this is called the sign distribution for x plus 2. Okay, so we can call this sign distribution. And this distribution is on the entire number line. For x minus 3, we have a similar situation, because if we have x equals to 3, x minus 3 is going to be 0, right? If we pick numbers such as 2, right? And so this is equal to 0. If we pick number x minus equals to 2, x minus 3 is going to be negative. So if we pick x equals 0, x minus 3 is going to be negative again. If I pick x equals to, say, larger than 3, 4, then x minus 3 is going to be positive. So, and so on and so forth, and ever after, right? X equals to 10, x minus 3 is going to be positive. So we got the sign distribution again. So from this pattern, right, we realize x plus x minus 3 also have some kind of sign distribution. Okay, so the sign, right? So the for x, so we have a similar observation about x minus 3, right? All numbers considered, right? So if x is equals to, if x equals to positive 3, x minus 3 is 0. X minus 3 is 0, right? If x is less than 3, x minus 3 is negative. And if x is larger than 3, x minus 3 is going to be positive, right? So we see another pattern. So similarly, we can draw a picture to describe this process. Okay, this is 0, sorry. So regarding the sign of x minus 3, the sign of x minus 3. So how is sign of x minus 3 distributed, right? So we're going to draw a number line again. Okay, so how is this sign distributed? So I'm going to find a place for 3, right? So for less than 3, right? For less than 3, x minus 3 is going to be what? It's going to be negative. for equal to 3 is 0. Larger than 3, positive. So we get a sign distribution for these two quantities in the product, right? So now we can follow the principle number 6 to realize, I see, right? Since x can be any real number, right? X can be any real number in domain perspective. So what I'm going to do is I'm going to line these up, right? So I'm going to look at x plus 2 and x minus 3. Okay, it doesn't matter actually whichever order, right? So we get, we look at these two, right? We look at these two two observations which reflect the sign distribution, right? So what do we see here, right? Because ultimately we need to look at the sign for x plus 2 multiply x minus 3, right? We want that to be positive, right? So for the sign of x plus 2 of x and x minus 3, all we have to discover is when the product is positive, right? So now since we have x plus 2, and this is x minus 3 distribution, so I line up those numbers, right? See -2 relative to 3. Now I'm going to make a number line to observe the sign of x plus 2 times x minus 3. So I have a number line. On this line, I basically have 3 number lines, but they're really just for observation, right? So -2 is here, number 3 is here, right? So the way I made it is that I made them line up. These are lining up, okay? 3 is larger than -2, so I reflect that on my number line. So 3 is larger than -2. So now I can figure out the sign of the product, okay? Because if you see, if I pick a number, right? Suppose I pick a number here. Okay, I pick a number here. I pick this number. This number obviously is less than -2. For less than -2, regarding this product, I have a negative times negative because this number has a place on x plus 2, x minus 3. So they are negative. So negative times negative. So for this number, and this is going to be positive. Okay, this is going to be positive. Okay, so for any number less than -2, the product is going to be positive because we encounter negative times negative. At -2, so when x equals to -2, we have a 0 multiplied negative number. So the product is going to be 0. Okay, in between -3 and a +2, -2 and +3, right? So I pick another number. And this number has a place on their number line. And you see in between -2 and 3, for x plus 2, that's a positive. For x minus 3, that's negative. So positive times negative. So in this interval, the product of these two quantities is going to be negative until we choose 3, right? If we choose 3, we have a positive number times 0. So that's going to be 0, 2. And last but not least, when you look at when I pick a number larger than 3, what will happen? It's a positive times positive. positive times positive are going to be positive. Okay, positive times positive is going to be positive. So now the distribution of the product is clear, right? The distribution of the product is clear. The sign of this product, less than -2 is positive, between -2 to 3 is negative, larger than 3 is positive. And what are we solving for? We are solving for all the x's such that the product is positive, right? Look at that. So we are solving for this piece. That's what we're solving for, right? So all of these analysis, right? We have reached the point. So now we look at the question we have. What are we solving for? We're solving for the product to be positive. So where do you think we can find our x's? And of course, we're going to find our x's where? And all of these numbers are solutions, and all of these numbers are solutions. Of course, these numbers are not solutions. -2 is not a solution. 3 is not a solution. So the solution would be what? So solution are all the numbers less than -2, or all the numbers larger than 3. And that problem is solved. And of course, you will say how I'm going to show work, right? So I'm going to show you how to show work. If you choose to use this method, if you choose to use this method, okay? So now I'm going to show you how to show work. Okay, so solution or show work. Okay, show work. What we do is here, you can basically, you don't need to do all of these. You don't need to do these analysis. I'm putting it here just to analyze and explain to you. Okay, explain to you. And for you, all you have to show is this piece. And your reader would understand completely. Okay, your reader will understand. All right, so you tell the reader about the sign of x plus 2, right? About the sign of x minus 3, about the sign of the product, and then you draw the conclusion that the solution to the given question is, okay, let me just make some more space here. Okay, so that's all you need to show. That's all you need to show. Okay, but this method is usually not visible, not as this method actually is rarely talked about in the recent textbooks. Okay, I use this method because I feel it's more illustrative. It's more illustrative. Most of the method in textbook they talk about is basically the tweak of this method. Okay, it says, so I call it method 2. Okay, what it does, the new method is, which is similar to this one, but uses tables. Uses tables. Okay, so what they do, this second method, okay, typically they would do the following. Okay, the second method to solve this inequality, right, for the same thing, solving this inequality is that they will first identify the numbers such that x plus 2 or x minus 3 changes sign. So the way they do it, okay, the second method, which is very commonly seen in textbook, is that they will set x plus 2 times x minus 3 equals to 0. Okay, they set it equal to 0. They set it equal to 0 for what? For what? They want to identify the value, basically identify the number -2 and +3 where the sign changes take place. Okay, you see x plus 2 is a negative, and then becomes positive, right? And -2 is the place where x plus 2 changes sign. Okay, let me say this. I'm going to put this narrative here. -2 is where x plus 2 changes sign. Okay, the same is to be said about this step. Okay, so 3 is where x minus 3 changes sign. So this step is to identify. You don't have to write down the this statement in the bracket, but you really need to understand. If you write it down, it doesn't do any harm. Make sure you write it down properly. Okay. So by setting this, equal to 0, so what you're going to find, you're going to have x plus 2 equals 0, or x minus 3 equals to 0. In fact, you can put this step in the previous question, in the previous method, in the first method. Okay, it doesn't hurt. So you could put this step in the first method. And then you get x equals to -2, or x equals to 3, right? But you need to understand why you do this, why we do this, right? The reason we do this is because on the number line, right, there's a number -2, and there's a number 3, which the product is going to be 0. At these two places, the product is 0, right? And we know that these are the two numbers where sign changes takes place. Okay, so let me write it down. These, okay, so x plus 2 times x minus 3 changes, I would say may change, because sometimes it doesn't, okay, may change sign at x equals to -2 or x plus 3. So that's why, okay, so let me put it as just think out aloud. Okay, just scratch paper. I will show you how to work with this method, okay? So we know that these are going to change sign. So what this table method does is that once we identify these two numbers, right, we know that at these two numbers, the product is 0, and we don't want it 0, right? So it divides the entire number line into 3 pieces. Okay, so these 3 pieces are the 3 intervals. One is from -∞ to -2. The next interval is from -2 to 3. And the third interval is going to be from 3 to +∞. Okay, so these are the 3 intervals we are going to observe the sign changes. Okay, so you're going to observe the sign for, you're going to observe the sign of x plus 2, right? And you're also going to observe the sign of x minus 3, right? And you might see this, you might have seen this before. So sign of the product. You can see it's very similar to what we shown before. It's really the same idea. It's really the same idea. Okay, So on this interval, right, how do we determine the sign? You pick a test point. You pick a test point, okay? For example, I'll pick a -3, right? And I plug in, right? So typically there will be a test point. Okay, so I'm gonna insert another column. Okay, so I'm gonna pick a test point. I'm gonna pick test point. Test points. Okay, we pick test point. In this interval, I'm gonna pick -3. In the second interval, I'm gonna pick 0. In the third interval, I'm gonna pick 4. So what is the sign of x plus 2 at the test point? Well, that's negative. What's the sign of x minus 3 at the test point? That's going to be -2. So negative times negative on this interval is going to be positive. Right? The sign of x plus 2, the sign of x minus 3, so the product is going to be negative times negative positive. At 0, x plus 2 is positive. At x minus 3 at 0, it's going to be negative. So positive times negative is negative. Now for 4, right? 4 on this interval, right? You take the 4, you plug in here, 4 plus 2, that's positive. And 4, you plug in here, 4 minus 3, that's positive. So positive times positive is positive. Okay. So, and then you look at the question asking us to do what? To make sure, finding all of those numbers such that the product is positive, right? So at this point, what is our solution? Well, this makes positive, this makes positive, right? And this makes negative. So what will be our solution? Solution, obviously, right? So the solution, of course, the same solutions, right? The solutions will be this interval, which means x is less than -2. Okay, or the next interval, which means x is larger than 3. Okay, the alternative solution will be given the interval solution. Hold on. Okay, or another way to express solution would be you just take these two intervals, right, and union the next interval. But as I told you, I prefer the inequality solution. Okay, so if I have you do the exercise, I will want you to write down the inequality solution. And of course, you can write here. You can also write this, right? You can write x less than -2, and here you can write -2 less than x less than 3, right? And here you can write x is larger than 3. Right, so these are the different ways of writing. They really mean different things. You can see that mathematics, you can write things differently, even though they mean the same thing. Okay, so this is the second method. This is a common method you will see in many textbooks, including pre-calculus textbook and a calculus textbook. But you can see the relationship. It's really just using principle number 6 and to design the whole method, Okay, so how do we show work here? So I'm going to show you how to show work in this case. How to show work, right? The first thing you do these. Okay, I think that would be nice if you show these. okay? Whether you write these commentary or not, but you should know it. You should know it. I have encountered student who does these. Okay, these student would do this, but if you ask them why you do this, and there's no answer, they don't understand. So you need to understand why you do this. So for that reason, I put this here. I hope you understand. And then you just put a table. Okay, you put a table. You put up a table and the solution, right? And that's it. Depending on what your professor wanted, okay, I told you what I want. I want this solution in inequality. Some professor may be okay with this one, okay? I want the inequality solution, okay? Because I feel like most of our students are not exposed enough to the inequality. So I want them to practice, okay? And they're very useful. They're very, very useful. So this is the second method. Okay, you can see the first method, second method. They really have the same idea. It's using the same principle, right? It's all about sign. Because the question in inequality is really, it's all about sign. We want the product to be positive, right? So this is the two methods which are very much connected. Method 3. Method 3 is a function method. Function method, we have talked about it. Okay, we have talked about this method. Okay, so what about this method? We mentioned this earlier, right? So for this question, right, what does that mean? We basically treat this as a function. Input, right? And we want, and this is the rule of the function, and we want the output to be positive, right? And we also understand this is a quadratic function. How do I know it's a quadratic function? Because if I FOIL, it's a quadratic function, right? So do I need to FOIL? I will tell you, you don't need to. We don't need to. You can just say, oh, x times x, that's going to be x squared. So it's going to be quadratic. It's going to be quadratic. We understand quadratic function and how to solve its inequality actually in the quadratic function section, right? I covered that. But here I'm taking it out to show you this again, right? Because we want the entire function to be positive, so in this case, we just find the x-intercept. So we're gonna set the function equal to 0. Okay, we set it equal to 0. So we set the output equal to 0. Why do we do that? We do that is to find x-intercept. Okay, we know that this as a parabola, this parabola opens up. It's a parabola, opens up, right? So once we find the x-intercept, which is x equals to -2, x equals to 3, and we can actually draw the picture. You can sketch the picture depending on whether, you can actually sketch it. You can actually sketch it, okay? So I'm gonna sketch the graph. Okay, I'm sketching the graph. Okay, so over here, and there. Okay, there we go. So I have a platform to plot points. So I know my x-intercepts. Okay, so I found my x-intercepts. Actually, I found 2. I have two x-intercepts, and these two x-intercepts are -2, 0, okay, and 3, 0, right? So I can find two spots on the graph. And should I put circle or dots? Should I put circle or dots? We should put circle. I will explain why. Why we put circle, right? Because we want the product to be positive. If it's a positive or 0, we will put a dot, right? That means at -2 and 3, they're not solutions because they will make it equal to 0, right? So that's why we put circle. So now if you sketch it, right? If you do this on paper, right? You don't have to precisely graph it, and the curve is going to be looking like this. It opens up and crosses x-axis, right, at these two places. And of course, we can get even precise picture because I have the tool, right? So just graphed it. Okay, so we got the curve. And this curve, it doesn't have to be even complete. You see, I still have part of the curve not showing because it doesn't matter, right? It really doesn't matter. So we want this product to be positive, meaning that we need to identify the input such that the output are positive. So where do we see positive output? This piece is a positive. That piece is positive. So the input we are looking for will be larger than 3, smaller than -2. Okay, we pretty much solved the question. Of course, we'll have to wrap it up and express it. So does that make sense to you? Okay, so this is the method we actually talk about in a quadratic function lesson, right? So here we just bring it up again. So this method is very visual. It's very visual. Okay, so let's please allow me to draw those red line, right? You're pretty familiar with. Okay, so the red bar, right? And we're going to draw the other piece on the other side. There. So these are the solutions such that the output are positive, right? And what are the output? The output is the product. The output, the product. And problem solved. So the solution would be the same. X is less than -2, or X is larger than 3. Of course, you know, I still favor the inequality solution. I still favor the inequality solution. Okay. So this is the third method, how to show work. How to show work. Okay, to show work, okay, I would write all of these. I would, okay. The sketching doesn't have to be perfect. So we assume it's a function, right? So reader knows you're thinking in the function perspective. And these parentheses in the bracket, it's optional for you to write it down or not. Okay, I would. And you found the x-intercept, and then you put it in the picture. And then you just tell the reader, hey, look, right? We want the product to be positive, and here we got it. Here we got it. When less than -2, greater than 3. You must have the word or though, okay? So all throughout these methods, you should have the word or. Okay, please have the word or. If you miss it, you might lose a point. So this is the third method. Do we have a fourth method? Do we have a fourth method? Actually, we do. We actually have a fourth method. But the fourth method requires some awareness about logic. Okay, we still use principle number 6, but we use principle number 6 in a different way. Okay, so here, since we are here, and from time to time, I always see students use this method. Some of them do it correctly, and some of them don't do it correctly. Okay. Normally, I would not cover this method in class because it could cause an array of confusion. Okay, I always have to correct it. So here, because for this class, I wouldn't be surprised someone is going to use it. Someone is going to use it. So I'm going to show you this method. This method uses logic. So it's called logical method. It's a great method to learn, especially you're heading to, programming, computer science, and STEM. So here it is. Okay. So what I do is that we treat this. So in my vision, right, I see this as A times B if A times B is positive. If A times B is positive. So this is the sentence that I'm reading, right? And of course, it comes with then. And as I said, it uses principle number 6. So I'm going to bring principle number 6 out here. Right? We talked about these principles earlier. Principle number 6 basically tell us that if the two numbers are the same sign, then the product will be positive. If the two numbers are opposite sign, they're going to be negative. Since we want it to be positive, so there are only these two cases. There are only these two cases. Okay. So here, what are we going to do? Okay. If A times B is positive, right? If you think about if two numbers are positive, so I'm going to write it as think out loud, right? So if the product is positive, there are only two cases, right? Either both are positive or both negative. Okay, so the then comes into two cases. Either both are positive, right? A is positive and B is positive. So A is positive and, okay, so you need to be carefully wording these, okay? And B is positive. So it must be and, okay? A is a positive and B is a positive. We have positive times positive is positive. So this is the first case we're addressing. The second case, I'm going to use or. A is negative and B is negative. Okay, so A is negative. Oops. And B is negative. This is the structure. You must put it correctly. Okay. And it's addressing this case. This and to addressing the second case. And it could be this case or that case. So or. So all of these words and or and must be correctly placed. If you don't get these correct, then you're going to be really in trouble. You're going to make mistakes. Okay, so this is the basic structure. So now we're going to use this basic structure. Okay, as they're applied to our situation. As they're applied to our situation, you know which one is A, which one is B, right? So A is x plus 2. Okay, A is x plus 2. B is x minus 3. Right? So you just put it in this structure. And because they are separated by OR, so you're basically solving this group and then you solve the other group separately. Okay, you solve the other group separately. So we basically have two separate structures. So on this side, I will get x larger than -2, right? And x is larger than 3. Okay. On the other part is an OR. So I'm getting x less than -2 and x less than 3. Okay, so you have to combine these two respectively. You have to combine these two respectively. In terms of how to write it, correctly, the way I show it on the screen is the right way to write it. Don't write them separately. Don't put or like beneath it. Okay, they have to be so when we read it, this has to be a coherent sentence. Okay, so if this is a positive, then A is greater than 0 and B is greater than 0, or A is less than 0 and B is less than 0. They have to be put on the same line. At least you read them in one breath. Okay, so for now, if you decide to use this method, write the way I do here. Okay, I actually don't see a lot of these methods being taught in the recent textbook, but this method certainly is there. It's out there. Okay, for example, when I was a student, this is the way I learned. Okay, but anyway, so then we're going to look at what's going on here, right? So for me, I would just put up a number line. I put up a number line. Okay, I'm going to see, this is the end, right? So I need to see the combination. I'm going to see a combination. So this is -2, right? This is -2. And this is 3, right? So I'm going to combine these two, see what I get, right? Larger than -2 and larger than 3, both have, remember, true and true is true, right? So what does it mean? So now you need to think of truth table. Okay, now you need to think of truth table. Larger than -2 are all of these numbers. Larger than 3 are all of these numbers. And is true if both are true. So combining these two, you have to look for the places where it's marked twice. That's where and is true. Here, the and is not true. Therefore, combining these two, we got, right? So this piece, we got x is larger than 3. So this branch, right? This branch, we got x greater than 3. The other branch, okay, we're going to be doing the same thing. Number line, and here's -2, and here's +3, right? So we have to see what do we get if we combine the end, right? Because it's and. So what is less than? What is less than -2? Less than -2 are here. What is less than 3? Less than 3 are here. All of these. So where it's being marked twice will make the and true. True and true is true. Therefore, on this piece, the answer is going to be x less than -2. So finally, okay, the final solution is you take this quantity, or don't forget the or, okay, is x larger than 3 or x less than -2, okay? So I'm going to put it x larger than 3 or x less than -2. It doesn't matter the order. You can reverse it. It's the same thing as what we showed before. Okay, so this is the basic structure of this logical method. Okay, this is the basic structure of the logical method. How do you show work? And this piece can be how you show your work. Okay, this piece. Okay, so this piece can be how you show work. You don't have to write this piece, right? But you need to have that in your mind. How to write it down on your paper? If you do this method, I want you to write the way exactly as I show here. Okay, I see a variety of problems using this method is that the reading is not cohesive. The logic is not clear. Because this method we do here, the power of it is without having to do the tables, without having to do those other things, is because it provides a very logical structure. So if you don't have that logical structure, and if the reader is lost, then you lose points, especially that reader is your professor, right? As someone teaches this method, even though I don't spend a lot of energy to promote this method because there are too much issues here, but I do encourage those of you to make some effort, because it's really good for your logical thinking and the STEM major. However, because this method is not taught in most of the textbooks I have encountered, therefore I kind of downplay it, right? Because the other three methods seem to be more illustrative, especially the third method, which is very, it can also be generalized. This method, the logical method, is kind of difficult to generalize. Can you imagine you have A, B, C, D, E greater than 0, right? Then your structure becomes very, very complicated. So this structure is good for logical construction when there A times B. If you have A, B, C, you have a more complicated situation. A, B, C, D is even more complicated, right? So it's good for logical training, but it may not be as practical. It may not be as practical. So the first three methods may be a better choice, okay? But anyway, I give you this method. And of course, I'll be very happy to answer your questions regarding this. But first thing first, if you choose to do this method, please respect this structure that I have presented here. This structure, if you totally understand it, okay, is the best way so far for me to present it properly. So one thing you understand, the other thing is that you have to present it properly so other readers understand, right? Other readers understand what you understand. So for that reason, I'm asking you to do it this way and to write it down this way, okay? Don't make changes until you get a complete, thorough understanding of this and present it nicely. Okay? So anyway, without further ado, I think this lesson is long enough. If I am to do more, it's probably going to be another lesson for the same topics, okay? So that's all for this lesson. Thank you for watching. Until next time.